The diagram shows a quadrilateral XBYA. The diagonals AB and XY intersect, so the diagonals intersect at M. Given that the area of the triangle AXB is equal to the area of the triangle AYB, prove that XY is bisected by AB. Okay, so I have to prove that XY is bisected, so I need to prove that this is the halfway point of XY. Basically, I have to prove that that line YM is equal to XM. So I need to prove XM is equal to YM. Okay, I'm going to add things to this to make it a little bit easier for myself. I'm going to add a vertical line. I'm going to call it vertical by putting in that right angle. I'm going to add one here as well. Okay. Right. I'm going to call it, what letter's not there, it doesn't really matter. There's no F there. I'll call it F for that point. I'm going to call this point G. And I'm going to redraw these triangles. So I'm going to come out here and I want to just redraw this triangle. So I've got, I'm going to draw them a little bit bigger. Let's colour them in white. I'm going to put my right angle in there as well. So remember, what I'm trying to do is, if I just XGM and FM and Y, remember what I'm trying to do is I'm trying to prove that that side is equal to that side. Well, let's give some proofs that I already know. I definitely know these two sides are the same. So I know that Fy is equal to Xg. And how do I know that? These are the heights of each of these triangles. So the vertical height, and I've been given that the areas of those triangles are equal. So if the areas are equal, so I definitely know that this line is equal to this line. I also know that this angle is equal to this angle, or that angle is equal to that angle. And I know that because so the angle FMY is equal to XMG vertically opposite angles are equal, so those two angles must be equal. Right, I'm going to use this knowledge that I have to find the line, the length of this line. Okay, so I'm going to use trigonometry, right angles trigonometry. So I'm going to look for the length of this. I'm going to label both triangles, and I'll do that at the same time. So I've got this angle, I know they're identical. There, opposite the angle, is O. Opposite that angle is O. The hypotenuse won't change. Hypotenuse, hypotenuse. And then the one that's left over must be A. I'm going to look for the length or how I find h. So I'm going to write down, as I normally would, I'm going to write down, silly old Harry climbed a high tree of apples. I'm going to use this trigonometry to help me prove. So what I have is I definitely need h in it, and I know that O is the same in both questions. So I know they're identical. So I'm going to use O and H. I'm going to use sine. So the sine, I just call this angle. No x's in there. There is, of course. I'm going to call this so y. There is. We call it angle Z. Call this angle Z because they are equal. So the sine of the angle, the sine of Z is O divided by H. Let's check this. O and H is there. I'm looking at this triangle here. So the sine of Z is O divided by H. So H must be O divided by sine Z. Now, if I was to do that exact thing to this triangle, I have the same thing again. I've got sine Z is O divided by H. That must make my hypotenuse equal to, cover that up, it tells me it's O divided by sine Z. Very difficult question, this. However, if H is equal to O divided by sine Z, and down here H is equal to O divided by sine Z, and I know that O is the same in both questions, and I know that Z is the same in both questions, that must mean that H is equal. So this hypotenuse and this hypotenuse are equal, or if I take it back to the question, this and this are equal. So I'm just going to write that statement to finish the question. If this proves that ym is equal to xm, therefore m is the halfway point of xy. It's a really difficult question there. Lots of stuff. You had to imagine these lines and then imagine the trigonometry on top of that. So a really difficult question.